Okay, take a look at this problem and see if this is steady or unsteady. This is unsteady because it will not continue forever. It has a termination point. Okay, so take a think about what you plan to do for this one. First thing I'm going to do is get the temperature. Give us some thought to how you're going to find the temperature. At the end, the system has saturated steam in there, and it's 100% quality because it's all vapor. So if it's saturated and you know the pressure is 200 kPa, you just simply look it up. You go to table, I think it's A6, the saturated tables, look for 200 kPa, and you find out that the temperature is 120.2. Just comes straight out of the table. So the next thing is to figure out what you're going to do to get the amount of mass that enters. If you've noticed the pattern, when these are unsteady, you oftentimes write the mass equation. So that's what I'm going to try and do, because they want the mass. I'm going to begin with the end in mind, and I'm going to try to write the mass equation and see what else I need. See if you can write the mass equation. Okay, for the mass, I have mass that comes in on the left-hand side. That's a positive, and that equals the final mass that's in the system minus the initial mass. I've circled the unknowns in blue, so I have two unknowns and I have one equation. So I need another equation. What else can you do? The next thing you can do is to write the energy equation. See if you can find write an energy equation for this. Here's my energy equation. I have mass that's flowing in times the H. Again, it's H because you have the U and you also have the flow work. That's why it's H. So HN. This term right here is expansion work because I'm expanding the piston. I'm expanding the volume. So it's a constant pressure. So if you remember, the expansion work is always the area under the PV diagram. Since P is constant, it's just a little rectangle. So this is the area of a rectangle. Or you can memorize the formula. But anyway, this is the expansion work. It's the pressure times V2 minus V1. It is energy that's leaving, because when you expand something, it's pushing you, it's giving you energy. So it's coming out of the gas and coming into what I can use. So that's why it's a negative, because it's leaving the system. So that's all of the energy that is coming or going, and there's no heat transfer because they said it's insulated. So there can't be any heat that goes in or out. And that equals the final energy. So at the end, you just have mass times internal energy. No H because it's not flowing inside the system, minus the initial energy, which is the initial mass times the initial U. So again, in the things in green, I'm hoping I'm going to be able to look those up in the table. But now I've picked up two extra unknowns. So now I have four unknowns. I used to have two, now I've got four, and I've got two equations. I need some more equations. What are you going to do? Since I picked up these extra volume unknowns, the thing that I thought was I'll write an equation for the volume in terms of the other things like mass. So can you write some equations for volumes and masses? Here are the ones that I came up with. Mass at the beginning times the specific volume at the beginning equals the volume, the big volume, the total volume at 1. And then I can also write it for the final. So now I have four equations. I have the black mass equation right there. I have the red energy equation, and I have these two black volume equations. So now I have four equations, and I have the same four unknowns that I had before. The things that are circled in green, I'm hoping I can look up in a table. Okay, so let's try to look them up. How are you going to find the values? For the initial state 1, I know the pressure and I know it's a mixture, so I need to find the quality, the value of X. Do you remember how to find that? The X is equal to the mass of gas divided by the total mass. See if you can find the X and then use the pressure in X to find the values at 1. At point 1, I know there's 6 kilograms of gas, and I know there's a total of 10 kilograms, so the quality is 0.6. I'm also given the pressure, so I'm going to look in the table for saturated, and I'm going to look up the liquids and the gas values for volume and U. Here's table A5. It's saturated water. It's the pressure table. I'm looking for a pressure of 200 kPa. So we'll scroll down till we find it. There it is. Let's see if I can put it on. There it is on the very bottom. I'm going to find the liquid volume. I'm going to find the gas volume. And I also want the U. So I'm going to find the liquid U. And I'm going to find the gas U. Remember, these are, you've got to multiply by 1,000 for the U's. Okay, so here are the values that I've copied out of the chart. Okay, what are you going to do about state 2? The final state. At the final state, the quality is 1. It's all gas. The pressure is the same pressure as it was before. So the volume at point 2 is the same as the gas at point 1. And the U at point 2 is the same as the gas at point 1. So that's the U. Okay, so how are you going to find the inlet value? What table are you going to use? To figure out what table, I need to find out if it's saturated or if it's superheated. So what I know is it has a pressure of 0.5 megapascals. That's 500 kilopascals. So I start off in the saturated A5 table, pressure table, and I'm looking for 500 kPa. So I just scroll down and I find 500. So the boiling temperature at that pressure would be 151 degrees centigrade, and I'm much hotter than that. So that means it's going to be a superheated vapor. So I'm going to go to the superheated tables. Okay, so here I'm at the superheated tables, and I'm looking for a pressure of 0.5 megapascals. So here we are, and the temperature is 350. So let me put it at the bottom. There we go. Let's see, 350. And I'm looking for the H going in, and I need just the H. Okay, so the H is this third column right here. So 3168.1. Again, multiply that by 1,000. Okay. Okay, so I've got all of the properties that I was looking for. The only thing that's left now is to solve for it. So take a look at how you're going to solve the equations, and then I'll come back and show you what I did. Okay, again, what I'm looking for is something that's quick and easy to do. So I started with this red energy equation, so I'm just going to copy it down over here. And so here's my red energy equation. And what I did was I plugged in the mass equations, the black mass equations for V and M. So that's these guys right here. So what I did was I said, okay, V2 is equal to mass 2, little v2. V1 is mass 1 times little v1. Also, I have a mass equation, a black mass equation for the Vn right here. So mass n, and I just put him in. So you have mass 2 minus mass 1, H, pressure, this is volume 2, big volume 2, this is big volume 1, and this is the same as over here, okay? So now I'm going to use the value of X and find the V1 and the U1. See if you can do that. Okay, here's the X equation for finding the mixture for the initial condition. The X was 0.6. This is the gas. This is 1 minus 0.6, and this is the liquid volume. And so I get a mixture volume of this. The internal energy for the mixture is the same X equation, just using different liquid and gas. Okay, so now that I have the values of U1 and V1, what are you going to do now? I decided what I'm going to do is take my energy equation here. I'm going to take these values and stick them in, and I'm going to solve for mass 2. So when I did that, I just gathered up everything that has a mass 2. So there's an HN, right? Here is a PV2 with a negative. And then I have, from over here, I have a U2, and I'm going to bring them to the left-hand side so it changes the sign. So this is everything that has a mass 2 in it. Then I'm going to gather up everything with a mass 1. And so here is a guy with a mass 1. So I have mass 1, and I have a negative HN, negative HN. Here I have a negative, negative, positive PV1. And then over here I'm going to grab this guy and pull him back over, and he becomes a positive U1. Okay? And that equals 0. So now I'm just going to continue to solve for it by plugging in values for everything. So you just take the mass 1 right here, your H, all your P's, and then you just divide by this term here, right? So you have mass 1, 10. This is the HN, right? And you flip the sign when you go over here. So that's your HN. This is a P times V, little v1, and this is the U1. And then I divided by this mess here. So I just plug the numbers in, crunch it out, you get a mass 2 of 29.06. Okay, that's not what they wanted. They wanted the mass that goes in. How are you going to find that? Yeah, that one's not too bad. The mass that goes in is the difference between the final mass minus the initial mass. So the mass that goes in is 19.06. What are the units here? Standard units. They would be kilograms. Okay, that's it.